All right, lesson number 13 is all about equilibrium. Equilibrium is when we have a reversible reaction, and at a certain point, the reaction going in a forward direction is equal to the reverse reaction, and that's equilibrium. All right, so in order to understand equilibrium, we talk about things called Q, which is the reaction quotient, and also K, which is the equilibrium constant. All right, so Q. Q we find always by looking at the equation. Now, phases are very important because if it's a solid or liquid, I don't include it in Q. But these are all aqueous, so they're all in there. If they were gas, they'd be in there as well. All right, so I start with my products. In this case, I only have one. I put its concentration there, and I square it because the 2 here. I then go to the reactants. I square this one. And the O2, I don't square. I can put a 1 there, but it's not important, so it's O2, right? This is different than when we were talking about kinetics. In kinetics, we actually have to go through some steps to figure out that rate law. Here, we just know based on the stoichiometry what to do. All right, so this is my Q. I'm going to use this for those 2 time periods that I have there. At time equals 0, we're told that SO2, so we have 1.2 molar SO2. Let's see, 2.5 molar O2, and 0 molar SO3. So now I can just plug these in there. So I have Q equals 0 squared, 1.2 squared, 2.5. Okay. I could do the math, but as soon as I see a 0 on top, I know it's 0, right? 0 times anything is going to get me 0, right? So if I only have reactants, I have no products in this case, my Q is equal to 0. Okay? Let's go through and let's do it at 250 seconds. At 250 seconds, this reaction has occurred. So I can plug in the values for that. Notice they're different. I have now 0.6. I now have 0.6 for my SO2. And I have 2.2 for my O2. Okay? So this has changed. Now, notice what's happened. My amount of product has increased, but the amount of reactant has decreased, right? That's because that's what happened, right? It's shifted from left to right. And based on the law of conservation of mass, if I gain product, I need to lose reactant. I'll show you this later on the thing. So I can go ahead and I can plug in my data, 0.6 squared. It's going to get me 0.36 over 0.36 times 2.2. This is going to get me 0.36 over 0.792. I then do that and I get 0.45. All right. Q and also K never have units. So even though all these are in molarity and I need to make sure they're all in the same units, Q and K don't have units, right? So that's just that. Okay, let's look at this on the screen. And when I do this, notice what I was talking about was my SO2 concentration decreased and my SO3 concentration increased, right? That's because if I'm going to form product, I'm going to lose some reactant, okay? All right, so I start off with my Q. Once I have that equation, I just plugged in, and I don't have units. All right, let's move on to video problem 13b. 13b dealt with a different reaction. This reaction, now instead of having just things that are homogeneous, right? They were all in the same phases. Now we have something that's heterogeneous, right? We have heterogeneous because they are in different phases or states. Okay, so we have this this reaction, and we're told that we have a solution that is 0.42 molar Cl minus and 1.35 molar calcium. Be careful, right? I remember when I wrote this, I tricked you guys by switching the calcium and chlorine, right? You can see on the top one, I had calcium first, then chlorine. Make sure you notice, okay, which one's calcium, which one's chloride. All right, so I want to go ahead and I want to find Q for this, okay? All right, so what do? I have to come up with an equation for Q. So this is going to be 1 over calcium 2 plus times chloride minus. Why isn't calcium chloride in there? Because it's solid. And if it's in solid, that means it's not in Q. But I have to put that 1 there. If I don't, right, this is going to give me a way bit different answer than this. Okay, so now I can plug them in. 1 over 1.35 0.42. Make sure you remember you're squaring that 0.42 and then multiplying by that 1.35. So that's 1 over 1.35 0.176. It's going to give me 1 over 0.238 or 4.2. That is my value for Q. Okay? So once I find my value for Q, now I can move on to the second part of equilibrium, and that's comparing my Q to my K. And I like to do a line chart. I say, okay, my Q is 4.2, and my K is 1.1. So what happens? My Q goes to my K. The reaction shifts from Q to get to equilibrium. Okay? All right, and so what this does is this goes ahead and it does something. Oh, so what's going to happen is it's going to shift left. Okay? And what we mean by shift left, that means my products are going to go ahead and they're going to form reactants. Okay? All right, we'll talk more about that in the next couple lessons. All right, here it is on the screen. We calculate Q, we can compare it to K, and then we figure out the shift. All right, talk to you guys next time. Have a good day.